Hello and welcome to Chapter 19, the digestive system. In the digestive system, we're going to look at general organization, look at the digestive tract itself and the accessory organs, talk about digestion in terms of the enzymes and the process, talk about absorption and where the stuff goes. In terms of regulation, I'm going to look a little bit about hormonal control and a little bit about the sympathetic and the parasympathetic. We're not going to touch eating disorders, and we don't have any time to look at any other disorders, but they're there for you to refer to with your pathology class coming up. When you look at the general function of the digestive system, it's not just to digest. You need to also absorb, and then it's very important you eliminate. So you must eat, break it down, get it into your blood, and poop it out. Poop out the waste. When we look at our digestive system, often we look at it as a tube inside a tube, and until the food actually gets broken down and into your blood supply, it is not part of you. It is an external part of you. So when we consider fecal matter was never really a part of us. Poop is stuff left over because there was nothing that was absorbed. We're also going to look at the digestive tract itself, the parts to it, and then we're going to look at the accessory organs. Accessories like a good bag or a good pair of shoes don't actually do the work, but they help accent it. The food does not go through the accessory organs, but it's very important to be used in digestion. When we look at the digestive tract, realize there are four layers. You have your mucosa, which is the epithelium and connective tissue and smooth tissue layer. Then you have your submucosa. Submucosa means below, so it's below the mucosa. Here is connective layer. A connective tissue, yes. Then you have a muscular layer. You have a smooth muscle, and you have it two layers of it. One is circular and one is longitudinal, so that way it can contract and squeeze, and it can also shorten. Remembering that muscles can only shorten. So if you want to change the direction of the shortening, you have to change the direction of the muscle. And we'll look at this again in the stomach when we add the third layer of muscle, which is transverse. All this has nervous control. Your nerves, your parasympathetic nervous system actually stimulates the digestive tract, and this is the part of the rest and digest. Your sympathetic nervous system will stop the digestion. That's why you shouldn't eat a half an hour after swimming, because your stomach will cramp up. Then you have the serosa on the outside, and this is connective tissue and epithelium, which is covering tissue. Okay? When we look at how everything is held together, it is important to realize you have these layers of membranes called omentum. You have the lesser omentum and you have the greater omentum. If you're a Dr. Oz fan at all, he talks a lot about the omentum. The omentum is connective tissue, which help keep has a good blood supply in it and help keep it together. There's also layers. There's the layers right next to the gut, so that's the visceral layer, and then you have the parietal layer. It's just important you know that there are layers. I won't quiz you on all of the layers. Then you have the peritoneal cavity. The peritoneal cavity is the space between the layers. The greater peritoneal is located in the abdomen, it extends into the pelvic cavity, and then you have the lesser cavity, which extends to the liver and back to the attachment of the diaphragm. Notice the diaphragm, although it's pushed up here, the diaphragm is the upper layer of the abdominal cavity. Very important. That's what keeps the guts below and the lungs and heart above. Okay? Now, the rectum is in here because the rectum is the end of the digestive system, but we also have the uterus and the bladder to show that the rectum comes out on the dorsal side, which you may not have thought of when you consider the holes down there, but First one is P, second one is for the uterus, and the third one is for the rectum, the poop chute, okay? This is important to realize that there's all sorts of connective tissue on there. So when you look at the medical shows and they just slice it and they can take out a digestive gland or pull out a big hunk of intestine, you can't, because everything is covered with these membranes which hold things together and also have a good blood supply and help keep the nerves in. But when you may have heard the word peritoneal cavity, when you have bleeding in the peritoneal cavity, if you have a ruptured appendix, it will go into the peritoneal cavity. So it is a cavity there which will hold, can hold fluid if you have abdominal fluid there. When we look at the general functions of the digestive tract, the digestive tract starts in the mouth. In the mouth you have teeth which break things down into smaller pieces, and then the tongue pushes it around. Being added to this is saliva, and the salivary glands come out of 3 different types of glands. You don't need to know the specific names, you just need to realize there are 3 of them. The salivary glands will produce salivary amylase, which is the chemical that starts breaking down starches. When we look at food, food is pretty much in 3 groups: starches, proteins, and fats. There are 2 types of starches: simple sugars and complex carbohydrates. The amylase will break down the complex carbohydrates into simple sugars. Okay, this starts in your mouth. The chewing breaks things down mechanically. The salivary glands add saliva, which start to break things down chemically. Then it is, let's also look at the words. Ingestion is getting food in. Mastication, that's a fancy word for chewing. And during mastication, you're breaking things down into smaller pieces. You're mixing with saliva. And then deglutination is swallowing. As you swallow, very important, you have your epiglottis at the back of your throat. As you swallow, the tongue will close the epiglottis, covering the windpipe or the trachea, allowing food down the right tube. If this epiglottis does not cover the trachea, that's when you get food and fluids into your windpipe, into your trachea, and a good cough usually brings it off. If not, you're choking. When you're choking, you get a good abdominal thrust and the air will force it back out. When it comes to teeth, human teeth have many different purposes for each different surface. You have the molars at the back, which are more for grinding. You have the cuspids at the front, which are more for ripping, and then you have the incisors for chewing or cutting. And these, you just need to be aware that there are different types of teeth for different things. These different teeth, if you do any comparative anatomy, you'll see that different teeth are more prominent in different animals, such as chewing animals like horses have more molars. Cutting animals like rabbits will have large incisors. Ripping animals like dogs and cats have larger canines. Another thing to notice, only because it's a very comical word and is often cited in TV shows, including The Big Bang Theory, the uvula. The uvula is the little the ball at the back of the neck, back of the throat. It is said that it may help close off the entrance to the nose during swallowing, but that's not always confirmed. Okay? Also, the teeth are not solid. They're layered and they have a root inside. The root and vessel inside the tooth. Again, you do not need to be aware of all the definitions of the tooth. Just realize you have a hard covering enamel and you have the pulp, which is where the root, the blood and the nerve tissue goes. Also, very important is the gingiva, which if you follow every single Listerine commercial, we're all dying of gingivitis, and that is inflammation of the gingiva or the gum. Also, all of this is held in the bone, so it is quite detailed. I want you to realize teeth are layered and detailed. They're not as simple as just like a peg inside the bone. Okay, after we're done swallowing, it goes to the esophagus. The esophagus is a food tube. The esophagus is where we see this first event called peristalsis, P-E-R-I, peri meaning around. Peristalsis is the muscular contraction that moves the food, called the bolus, down into your stomach. And the stomach is where no digestion occurs in the esophagus, and it passes through the diaphragm at this part called the esophageal hiatus. So if we look at our picture of our stomach, there is a break in the esophagus. The problem with having a break, in the diaphragm, the break in the diaphragm is the esophagus can get stuck in it, or the stomach can try and get out of it. Either way, you're going to have pain, or it can close too tight and you end up with food not getting down it. Now, the esophagus leads to the stomach. The stomach is very acidically, so sometimes if the stomach juices go back up the esophagus, it is what they call heartburn, which is a total misnomer because it should actually be called esophageal burn, because it's the acid that's burning your esophagus. Okay? So the esophagus is a muscular tube which pushes the food down to the stomach. No digestion is done at that time. Then we get to the stomach. Notice the stomach has 3 layers. We have our longitudinal layer, which contract up and down, circular layer, which will contract round and round, and then the oblique layer. The oblique layer goes sideways, allowing for greater churning. It's this muscular churning that will help mix up the juices in the stomach, and will also start mixing up creating the stomach into more of a paste called chyme, C-H-Y-M-E. And that paste will then go out into the small intestine. There are sort of areas in the stomach. You have the fundus, you have the pylorus, and then you have the lumen. Lumen is just another word for big opening. You also have sphincters, which are circular muscles at the top, which close off you have the lower esophageal sphincter, sometimes called the cardiac sphincter because it's one near the heart. Then you have the pyloric sphincter. The pyloric sphincter is on the pylorus section, and it prevents the food to go into the duodenum. This allows this to be a closed off area for churning. Now, the stomach is where proteins start to get their digestion, and only proteins start here. And we'll get into a little more detail on that, but it is the hydrochloric acid that is released from the stomach cells, the lining of the stomach cells, and also an enzyme called pepsinogen, which turns into pepsin, and pepsin breaks proteins down to peptides. Talk a little bit more about that later when we get to the chemistry of it. Then once we are done in the stomach, we go into the intestine. So we're going to start in the small intestine. The small intestine comes off here. Now, it's hard to believe, but there are 7 meters. That's probably the distance across a classroom. 7 meters of guts in here. So it's folded up pretty tight. The small intestine has the duodenum, which is the first one, then the jejunum, and then the ileum. The duodenum, duo means 2, denum means 10, so 10 and 2 is 12. It is the first 12 inches of the small intestine. There is no distinct area where the jejunum and the ileum divide off. You can just tell them by the lack of villi or folds. Now, the small intestine has a lot going on into it because it is in the small intestine that the accessory organs of the pancreas and the liver or the enzymes from them will dump in. Also, I want to talk a little bit more about the structure of the small intestine, so I will do that in video 2 because I'm running out of time.